This time, let's study another sorting algorithm called Insertion Sort. Insertion Sort performs sorting of elements just like with other sorting algorithms, but it takes a different process. For us to see how the process of insertion sort happens, let's review the algorithm of insertion sort. The first step is to work from left going to the right of our dataset. Then as you move to the right, you have to compare the items on its left. If the left item is bigger than the right item, perform swap. But if it is false, then you have to go back to the first step and then continue to the next steps. Now let's watch the simulation of insertion sort. Let's take these numbers as our sample dataset. We start from the first element, and since there is no item on the left side of this element, we need to move forward. Now the current element is 2. We need to compare the left element, which in this case 3, to the current element, which is 2. And we know that the left element is greater than the current element, therefore we have to do swapping. And then we move forward. The current element is now 5, and its left element is 3. We need to compare this left element and the current element, the 3 and 5. And we know that 3 is not greater than 5. It means that we don't need to do any swapping. Continue moving forward. The current element is now 7, and its left element is 5. And we know that 5 is not greater than 7. So we cannot perform any swapping. That is why we have to move to the right side. The current element is now 6, and the left element is 7. And we know that 7 is greater than 6. Therefore, we have to do swapping. 7 will become 6, and 6 will become 7. And since swap has occurred, we need to examine the previous elements. So let's see if the newly swapped element, which is 6, is greater to its left element, which is 5. And in this case, 5 is not greater than 6. So therefore, we don't need to do any swapping. Now let's move to the right. The current element now is 1, and its left element is 7. And 7 is greater than 1, so therefore we need to swap 7 and 1. And since swapping had occurred, we need to move to the previous element, examining each element which is greater. In this case, we have to examine 6 and 1. And we know that 6 is greater than 1, so we need to swap 6 and 1. Again, swapping had occurred, so let's move to the previous elements. And we know that 5 is greater than 1, so we need to perform swapping. And again, swapping had occurred, so we need to move on the previous elements. And we know that 3 is greater than 1, we need to do swapping. And again, swapping had occurred, so let's move to the previous elements. And we know that 2 is greater than 1, so we need to swap these numbers. And since we have already completed comparing all the elements to each other, we are now through with our sorting. Dataset is now sorted. To start writing our algorithms for insertion sort, we will make use of the examples that we had on our bubble sort algorithm. So just a sort of review before we start writing our algorithm for insertion. Maybe you can still remember that we created a class, and the name of that class is collection with 3 private variables. And then we created a constructor here, initializing the size of our array. And then we have a method for inserting elements in our array, and then another method for displaying the elements of our array, and then another method for clearing the items or the elements of our array, and then a property for getting the length of our array. So now what we will do is to go back to our main method and then start explaining this line by line. We created a number object here out of C collection class, and then we also created a random object here, and the name is RDM. And then we created a loop here, inserting each item from the numbers given by the RDM random object. So it will generate random numbers from 10 to 90. And those numbers will be inserted on our number C collection object. And then after that, we display those items from our array. And then the next method that we will do is the insertion sort method. But before we start, let's try running the application first. Okay, so there you go. So we have 20 items here, unsorted elements. To start writing our insertion sort algorithm, we will go at the bottom, and then at this section, this is the place where we will add our insertion sort. So let's write here public void insertion sort. And then we have to do a loop statement starting from the first index, which is 0, going to the upper limit of our array. But since in our insertion sort algorithm, we compare the right element to the left element. And for that to happen, we have to change this to 1 so that we can have a left element. Because we know that our first index is 0, and 0 has no left element. So that for us to have a left element, we have to move forward by changing our initial position to 1. And then after that, we will create a temporary variable here in the name of I, or in the name of j, and then initialize this with the value of I. We will write a while statement here that will examine if we need to do swapping. So while j is greater than 0, and at the same time, our num on the left side element of our element is greater than the right side of our array. So if it happens that the left side is greater than the right side, then what we will do is to do swapping. We will create here an integer variable, let's say temp, and then initialize this with the value of the left element in the name of num j minus 1. And then we will overwrite the j minus 1, that is the left element, with the right element. And then same thing with the right element. We will overwrite our right element with the left element. Okay, there you go. And then as we do this, we have to subtract our j by 1 so that it will be able to move to the previous elements if there is still items that needed to be swapped. Okay, so there you go. Then let's give this a try. Let's go back to our main method. And then on this part, we will write here. Let's copy and paste this one. And then copy paste this again. And then we will put a text here, sorted text, informing our user that this is the sorted portion. And then just before our sorted text, we will state here number dot insertion sort. Okay, so let's give this a try. Okay, so we have an error here. It says index was outside the bounds of the array. Okay, so this is normal error. Whenever we work on array, we have to make sure that all elements will not out of bounds from the given indices. Okay, so I guess the problem here is instead of writing 1 here, we wrote here I. So let's replace this. Let's replace this with 1. Okay, so let's give it a try again. Okay, so there you go. The unsorted starts with 18, followed by 20, 41, up to 81. Then after performing insertion sort, now the element started at 14, followed by 15, and then up to 85. We were able to sort the numbers from our dataset using the insertion sort algorithm. So that's the end of this video, and see you in the next lectures.